This is clip number 2 for lesson 1.6, learning target number 4, solving systems of equations using elimination. In the first video clip, we went over several examples that follow these steps. And in this clip, I've asked you to try 2 problems that I'm going to work out in a second. If you did get one of them correct, feel free to fast forward to the next one. Number 1, step 1 is to target the variable to eliminate. Step 2 is to use multiplication to make coefficients opposites on one of the variables. Step 3 is to add the equations together vertically. Step 4, solve for the remaining variable. And step 5, plugging that answer that you just got back into the original equations to find the other variable. You were asked to try problems A and B for now. So if you did these correctly, then you can always fast forward to the final answer if you just want to check your answer. But if you need to see the steps, here they are. For this particular problem, for letter A, you could target the variable x or the variable y because neither of those are exact opposites, and neither of those has a coefficient of 1 that I could just multiply one of the equations. I am going to choose to target x, but if you targeted y, you could follow along to see how x works, and I can look at it with you in class on where you may have made your mistake targeting y. To target x, the least common multiple is 10. So that means my top equation has to get multiplied by 2 to make this negative 10x. Some of you might have multiplied by negative 2 if you wanted that to be the positive one. And my bottom equation has to be multiplied by 5 to make that become the positive 10x. When I distribute the 2 into the top equation, I get negative 10x plus 4y equals 64. When I distribute the 5 to the bottom equation, I get positive 10x plus 15y equals 50. So my equations are still balanced. It's the same system. It just looks different. Now that we have these as opposites, our next step is to add the 2 equations vertically. My x's are eliminated. That was the whole point of targeting them. My y's become 19y equals 114. So now I'm going to do 114 divided by 19, and it's 6 exactly. So this means that the point, I don't know the ordered pair yet, but our solution is something comma 6. I found the answer to the y variable first. So now I'm going to take that answer and plug it into my top equation. In my top equation, that's negative 5x plus 2 times 6 equals 32. 2 times 6 is 12. So I take away 12 from both sides. Negative 5x equals 20. When I divide by negative 5, I get x equals negative 4. As long as I did all my algebra right, that should work. Now, so I think my point is negative 4, 6. What I'm going to do is take this x and this y, since I got this from the top equation, take these numbers and put them into the bottom equation. 2 times x plus 3 times y equals 10. My y was 6. So 2 times the x plus 3 times the y equals 10 is the bottom equation of my original system. This is negative 8, this is 18, and negative 8 plus 18 is 10. So we know we have the correct answers. The correct answer for letter A is negative 4, 6. Let's take a look at letter B. For letter B, this top equation is in standard form. Unfortunately, our bottom equation is not in standard form. I need to take away 24 to move the constant to the other side. And you can do this simultaneously or separately. I need to take away 3w to move it from this side to this side. This gives me the top equation being 2w plus 3z equals 17, just as it originally appeared. My bottom equation now being negative 3w minus 4z equals negative 24. So it's still balanced because I used inverse operations of addition and subtraction to move these away, or to move the variable to the other side to get it in standard form. Now, it doesn't matter whether you target w or z. If you want, you can call them x and y, but make sure you label, like let w equal x, let z equal y, and then you change them all, and then in the end you change them back. But most of you will be okay working with the other variables. So I'm actually going to target, it doesn't matter which one I target, I'm going to target this because its least common multiple is smaller. This has a least common multiple of 12. This least common multiple is 6. And I think 6 is easier to work with than 12, or smaller things to multiply by anyhow. To get this to be 6w on top, and this to be negative 6w on bottom, what times 2 is 6? That would be 3. I'm going to multiply my top equation by 3. So I'm going to do that right now. That's going to give me 6w plus 9z equals 3 times 17, which is 51. On my bottom equation, to get this to be a negative 6w, we already have negative 3. I just have to multiply by 2. So that's going to be negative 6w minus 8z equals negative 48. Because 2 times negative 24 is negative 48. So now that we got it in standard form, targeted one variable, and now got them to have opposite coefficients, we can eliminate w when we add the two equations together vertically, giving us z equals, that's going to be 3. Z equals 3. So in our solution, which as an ordered pair is a little weird, but alphabetically it would be w comma z, z is 3. We just have to figure out what w is. So I go back to my original equations. In my original equation, I have 2w plus 3 times z equals 17. And in the bottom equation, which I'll check in a second, that's the one I'm going to check last. So I've got 2w plus 3 times z is 3, so I can plug 3 in. So this is 2w plus 9 equals 17. Take away 9 from both sides, we get 2w equals 8. When I divide both sides by 2, w is 4. Okay, so now we have our ordered pair, which we believe is 4 comma 3. That's our w comma z, 4 comma 3. I got the w from putting it in the top equation, so I'm going to check this using the bottom equation, that 24 minus 4 times z, z is 3, should actually equal 3 times w, and w is 4. Well, that says 24 minus 12 equals 12, which it does. So I know that this point is the correct solution to this system of equations. Have a great day.